So we'll solve some problem based on volume strength of H2O2. So let us see how to solve this problem. So by practicing these questions, we can understand how to solve any kind of questions. So here I have collected some questions. Half liter of each of the 3 samples of H2O2 labeled 10 volume, 15 volume, 20 volume are mixed. These 3 volumes are mixed and then diluted with equal volume water. So these 3 volumes are with half liter they mixed and again diluted with the same amount of water also. Calculate the relative strength of the resultant H2O2 solution. So we have 3 volumes, so we'll take the equation normality. So normality of the sum of the normality of this 3 volume will be equal to the normality of the final volume. So right here N1 V1 plus N2 V2 okay plus N3 V3. So this will be your N final volume into V final volume. Okay, so V final with after dilution with water. Okay, with water. So what will happen? So N1 given here. So N1, you know volume strength. So volume strength formula is N into 5.6. So we'll get here N means volume strength by 5.6. This means if it is given 10 volume, this will be your 10 by 5.6. So first will be your this implies that 10 upon 5.6. So here volume is given how much? 500 ml. Second is your 15 divided by 5.6, 500 ml, and third is your 20 divided by 5.6, and again volume 500. Now they diluted with the water also. So water, so there are 3 volume, this and plus water. So normality of the final will be how much? So volume is 1500 before 5 into 3 and 300 into 500. So this is for water. Same volume, so it becomes 3000. So again normality of the final volume will be, so again this will be your 500 common, 5.6 common. So this will be 3000. So we can write here 500 by this will be your 3000 into normality. This is 500 by 5.6 and multiplied by here 10 plus 25 plus 40 will be 45. Okay, so again we can see here this will cancel, this will be your 6. So again normality of final volume, so normality will be your how much given here? So normality will be here 40. So this is your 45 by here 5.6. so 45 by this normality will be, we have to find the strength. So again 45 by 6 divided by 5.6. okay, so now this volume strength will be how much? So volume strength will be normality into 5 by 6. So we can divide this one. So 45 by, so we have to find, so n into 5.6. so this will be nothing but the volume strength by 5 by 6. So again this is nothing but the volume strength by 5 by 6. So 45 by 6 divided by 1 by 5 by 6. So this will be cancelled. So again solving, so we will get answer here 7.5. So this is our volume strength of resultant volume strength of the solutions. So here milliequivalent of H2O solutions reacted with the 80 ml of 0.05 molarity KMnO4 solution in acidic medium. So again, what is the volume strength of H2O2? So we have to find the volume of H2O2. So again we will solve problem. So we can use milliequivalent of H2O2 is equal to how much? So this will be your milliequivalent of KMnO. So we can use this value, milliequivalent value. Okay, so you should know what is milliequivalent each cases. So for H2O2 it is given here normality into volume. So volume given here 20. So we can write here 20 into normality we don't know. For KMnO4 given here 0.05 into this is molarity. So n factor will be your 5. N factor why? Because Mn plus 7 is coming to Mn plus 2. So this is in acidic medium H plus. So n factor will be your 5. So 5, and again volume they have given here 80. So if you solve it, so normality of H2O2 will come about 1. Now volume strength, so this is volume strength is nothing but the volume strength will be normality into 5.6. So normality is given here 1. So 1 by 5.6 it will be equal to 5.6 volume strength. So this is the volume strength of this H2O2 solution. In this question, 40 gram barium permanganate molecular mass is 375 sample containing some inert impurities in acidic medium is completely reacted with 125 ml of 33 point. This is the 0.6 volume of H2O2. So what is the percentage purity of the sample? So we have to find the percent pure sample. So again, it is milli equivalent of barium permanganate. So MnO4 whole twice is equal to milli equivalent of H2O2. Okay, this is milli equivalent given here. So here milli equivalent is nothing but the barium weight of the molecular mass of the barium permanganate, moles of the barium permanganate. So here again multiplied by 10. So here n factor, this is n factor is 10. How 10? Because if you see here manganese is plus 7 state, so it will convert into plus 2 states. So here we have 2 manganese, so n factor will be your 5 into 2, so this will be 10. So n factor is 10 here. So again multiplied by the volumes, not volume. So milli equivalent here, so you have to write here 1000 because this will be weight. So here we have to write here how much volume is given. Volume is given here 125, and the n factor will be your 2, and here weight of the H2O2 is given how much. So it is 33.6 volume and divided by molar mass, that is 2 liter. So this is the 33.6 is the oxygen, and divided by the this one volume of the 1 ml of the H2O2 is giving 1 ml H2O2 will give how much. So this will give you 22.4 liters. So not only it will give you 11.2 liters. Okay, so 33.6 will give you number of moles. Okay, so here this is your milli equivalent of H2O2. So now from here weight will be how much. So weight will be, if you solve it, so it will comes about weight 28.125 is weight there. Now percentage purity, so percentage purity is weight is 28.135, and again they have given here 40, so multiplied by 100. So this is 40 there, multiplied by 100. So if you solve, you will get here 70.31. So this is the basically percentage purity of the sample. 25 ml of H2O solutions were added to excess acidified solution of potassium iodide. The iodine so liberated required 20 ml of 0.1 normal sodium hyposulfate for titration. So this is titrated with the hypo. Calculate the strength of H2O2 in terms of normality, percentage and volume. So again we have to equate it. So here we write milli equivalent of H2O2 is equal to milli equivalent of I2. Okay, and this is again equivalent to milli equivalent of Na2S2, and this is O3. So again here we know that normality is normative H2O2 into, so here volume they have given 25, and milli equivalent of I2 is given here, which is IT is titrated with this hypo. So directly we will write here hypo. So hypo is given here 0.1 into 20. So normality of H2O2 will be how much? 0.08. So again we want to find it mass. So mass of H2O2, so per liter. So mass of H2O2 per liter will be how much? This is per liter is there. So right here 0.08. So this is the equivalent weight, and multiplied by 34 into 2. So this is nothing but the normality into equivalent weight. So this will give you mass of the H2O2 per liter. So on solving we will get here 1.36 gram. Now percentage by mass. So percentage, second part, percentage by mass will be how much? So percentage by mass, so this is per liter. So this is we are getting in 100 ml solution. So here we want 100 ml. So in 100 ml, what is the percentage mass? This will be your 136 gram. This is per 100 gram. So again percentage by volume if you want. So percentage by volume will be 56 by 17. Use the formula and multiplied by mass percent. So if you multiply mass percent, this will give 56 by 70 into mass percentage 0.36. So here we will get answers 0.448. 5.8 volume. So this is our volume, this is our mass, and again this is the mass of the H2. Okay, and this is the normality. So keep it, 3 values are there. So this is our basically answer. 5 centimeter solutions of H2O2 liberates 0.508 gram of iodine from an acidified potassium iodide solution. So calculate the strength of H2O2 solution in terms of volume strength at STP. So we have to calculate the volume strength again here. So again you can use this concept, milli equivalent of H2O2 is equal to milli equivalent of here I2. Okay, so again we can use here. So weight is given here, weight is weight by 17, that is the gram equivalent into 1000. So this will be equal to, again milli equal to I2 will be, so weight by equivalent weight, so 508, and molecular weight is given here 254. So this is the equivalent of I2. So I2 is divided by 2. So this is the molecular weight of I2 is 1727 into 2 for I2. So this is nothing but the 2 to the power 2. So this is the equivalent, and again multiplied by 1000. So here W will become about 0.6 gram, 68 gram. Okay, sorry, 68 gram. So this is the weight of the H2O2 per liter. Now we see here. So if H2O2 if you heat it, what will happen? It will give you water plus half oxygen. It will give water plus half oxygen. So 34 gram is given how much oxygen? So 11.2 liters. So but here we require how much? 0.068 gram. So 0.068 gram will give how much ml of oxygen? So it is very simple, divided 34 and multiplied by 0.068. So on solving we will get here 22.4 ml of oxygen. So this is given by how much? So it is given by 5 ml. So this much solution is given by 5 ml of H2O2 solution. So for volume strength we measure for per ml. So volume strength will be how much? So for per ml will be how much? So per ml will be your, this is the total volume strength. So per ml, for 5 ml will be per ml will be how much? So 11 point, this will be your 22.4 divided by 5. So this will becomes here 4.48 volume. So this is the volume strength at STP. 80 ml of H2O2 react completely with 15.8 gram of KMnO4 in acidic medium. Then what is the volume strength of H2O2? So again I write here milli equivalent of H2O2 is equal to milli equivalent of KMnO4. Okay, so this is the given here. So again by using the equations, question number 6, we are solving question number 6. So this is nothing but the 280 by let's take the weight of H2O2 is x gram and divide by this is your 5.6. so 5.6 is the normality, not normality, 280 into x by 5.6. so this will be your milli equivalent of KMnO4 is how much? So again write here 50.8 gram and divide by here 158 by 5. So because in acidic medium and factor of the KMnO4 is 5. So again we multiplied by 1000. So here we will get here. So it is given here. So why we are taking this value? So this is nothing but we know that the volume strength is equal to suppose you are taking x, so this is normally into 5.6. so here normality will be your x by 5.6. so we are putting directly this value. This is not the normality. So again we solve it. So this will come about 50x minus 15.8 into 5 divided by 158 so into 1000. So here x will be, if you solve it, it will come about 10. So 10 is our volume strength of H2O2. Now we will see next question. So next question is this one. So 0.2 gram of a sample of H2O2 is required to this one 10 ml of 1 KMnO4 in a titration in presence of H2O2. So what is the purity of H2O2? So this is given here H2O2. So again we will go through this equation. So milli equivalent of H2O2, milli equivalent to H2O2 is equal to how much they have given here 10 ml of KMnO4, so we can write here milli equivalent of KMnO4 in acidic medium. So this is equal to 10 into 1, so directly we can write a milli equivalent of weight of H2O2 will be your 10 into 10 to the power minus 3 and multiplied by their equivalent weight. So 17 is the equivalent weight, so here, so we will get answer here 0.17 gram. So what is the percentage purity of H2O2? So percentage purity of H2O2 will be, so total given here 0.7 gram and divided by 0.2 gram and multiplied by 100. So if you solve it, you will get answer here 85%. So this is our answer. This is a very looks like a very long questions, okay, but the answer is very simple and easy. A solution of H2O2 labeled as 20 volume was left open, okay. So this volume left open, and due to this what happens, some H2O2 decomposed, okay. After decomposition, the volume strength of the solution is decreased. So to determine the new volume strength of the H2O2 solutions, 10 ml of that solution was taken and it was diluted to 100 ml, okay. The 10 ml of this means out of 100 ml solutions, so from that 10 ml solutions it was titrated against the 25 ml of 0.0245 molarity of KMnO4 solution under acidic condition. So calculate the volume strength of the H2O2 solution. So again we use the same concept, that is milli equivalent of H2O2 is equal to milli equivalent of KMnO4, okay. So this we are talking about the diluted solution. In mind it, we are talking diluted solutions, which is 100 ml, okay, which is 100 ml. So this ml we are talking it. So again right here normality of H2O2 will be your 10, we have taken here 10 ml. So 10 ml of this 10 ml we are taking, this 10 ml is there. Now milli equivalent KMnO4 is how much? 25 into 0.245, okay. So here normality of 10 ml is how much? H2O2 for 10 ml solution is 0.08 normal, okay. So now if you take this is normal, if you take 10 ml, 100 ml or 1, it will be same. So now we are diluting, so normality of H2O2 for 100 ml solution will be how much? This will be again same, or 10 mol or 100, it will be same. So value will be your same, okay. But what is the original value? So original value to determine the new volume of the H2O2 solution. So 10 ml of solution was taken, it was diluted to 100 ml. So this is the 100 ml. So it was diluted to 100 ml. From that 100 ml, 10 ml taken, okay. So that we have to make it original solution 10 ml. So this N2O2 for 10 ml. So this was diluted. This was diluted. Now this is original solution. So original solution means 10 ml they have taken. So normality of original, we can write original 10 ml solution, 10 ml solution. So here what will happen, this 100 ml, so this much for 10 ml solution, so it will divide by 2. So answer will be your 0.308 divided by 10. So we will get here 3.08. So this is the normality. This is the normality of the 10 ml solutions. Now what is the volume strength of this solution? Okay, so which is the volume strength of this solution? So nothing but the normality into 5.6. So here normality we know that 3.08 multiplied by 5.6. So if we solve it, so we will get here 17.13. So this is the volume strength V. This is the volume strength of original solution which was left open 20 volume. So initially 21. So how much lost? So lost was, we can see lost volume was 20 minus 17.13. So it will be your so if you calculate this, so it will be 2.7. So it will be your 10 minus 3 7 and carry you 90, not 90, 87 and point. So 2.87 volume was lost. So this is basically our answer.